Good evening, and welcome to this very special event featuring truly one of the world's foremost leaders in trying to build a sustainable future for us all. I want to briefly mention this event is co-sponsored by Denon, our new Delaware Environment Institute, as part of its dialogue series. Also, my center, I'm John Byrne, in case some of you don't know. Center for Energy and Environmental Policy's annual policy colloquium series, the Center for Political Communications as part of its Global Agenda series, and of course the College of Agriculture and Natural Sciences, which really helped us to pull this together. I'd like to make a few remarks to introduce our speaker tonight, whom I have known. I feel great privilege to count him as a friend for a very long time. He is a pioneer in the fields of energy change, sustainable development, and of course climate change. As is the definition of a pioneer, he has advanced ideas and took actions on ideas far before others have. And our university was actually blessed as a location for him to try a set of his ideas. This goes back to the early 1990s, and I have a rather less elegant than is the modern approach these days, but this was a brochure for a program in energy, environment, resources, and sustainability, jointly organized by TERI, the Energy Research Institute that our speaker created and launched, and the University of Delaware, including the Center for Energy and Environmental Policy. And it was an interesting program. This is back in the early 1990s. I don't know if all of you can even relate to that far back, but it was an interesting program. The intention was to develop a stream of ideas and practices for folks from different parts of the world sharing both their contexts and their knowledge needs in order to produce practical, sustainability-based projects through the program. They spent 8 weeks in India, spent 6 weeks here at the University of Delaware, and then had 4 weeks to implement a real, with a budget, sustainability project in the various organizations that they came from. They included science-based organizations, businesses, the media, universities, and government. And it was really, I think, one of the more interesting, and for many of us here who were able to participate in it, one of the more rewarding programs that we have ever had the chance to work on. And I have to say it has success on many levels, including where its participants have ended up and some of the very interesting networks that have been created from those days. So the University of Delaware was an incubator for this speaker in developing some of the new ideas that we now depend upon as a society and our greater dialogue in the world community on how we solve a truly difficult problem for all of us. When he took responsibilities of chairing the Intergovernmental Panel on Climate Change, the Ipcc, our speaker sought to create on a grand scale a knowledge network to save our planets and our human communities, to serve our planet and to serve our human communities' needs to address one of the most difficult problems of our era. This problem has not gotten easier. In fact, it has gotten more difficult. And it has not been easy to serve as chair of the Ipcc. In fact, Ipcc leadership has had to meet the challenges made by powerful governments, businesses, and special interests who, as they see it, stand to lose if we actually address the serious problem of climate change. Yet our speaker has stood for the evidence and with the evidence in all cases to try and get us to act on the basis of the best available knowledge that we have about this problem. His courage has proved to be right every time. The U.S. National Academies visited this issue, both about the Ipcc's evidence and through its own independent scientific panel on this question, and came to the common conclusion that the risk of climate change is real and the need for global action is urgent. The British Royal Academy similarly recently confirmed what the Ipcc has been saying to all of us, as has many academies throughout Europe. China's and India's top research organizations have reached common ground on this issue. Africa's top researchers and organizations have joined in this effort, as have those scientists and top research organizations in Latin America, where in particular biodiversity is at great risk because of the problem of climate change. More than 150 governments have now recorded their conclusion that action is needed urgently. That does not necessarily include the government of this country. Our speaker continues to invite any and all to bring forward new thinking and new evidence on this problem and to help us make progress on trying to address the issue. And in that regard, I would like to simply give you my portrait of this individual. He's a person with courage to cajole us to do what is not easy. He has been asking us since 2002 to take the actions that will not be easy for us to do, but are essential for our grandchildren's and our great-grandchildren's future. He's a person who stands for evidence when it is not popular to do so, and he is a person who deeply respects debate and invites everyone to join in the discussion of this problem. With pride, we can say that he joined our community for an evening, this evening, to share ideas and to consider the need for action. Will you please give not simply a warm welcome, but a very strong and rousing welcome to one of the true leaders on this planet for a sustainable future, Dr. Rajendra Pachauri.
Thank you very much, JB. And I'd like to request the audience to discount everything that he said. Well, he's a friend, so he would exaggerate in giving me this extremely generous introduction. May I say it's a great delight to be back here, to be among friends, and to be in this great institution. I believe the future will really be decided by the power of intellectual activity, because it's really knowledge, the dissemination of knowledge, which of course has to be accompanied by debate and discussion, that's going to chart out the future of human society. I'm particularly happy to be here because when I had the privilege of accepting the Nobel Peace Prize on behalf of the Ipcc, we had a debate beginning at that time on what to do with the money that came to the Ipcc. And several people suggested things like making small little gold medals and giving it to all the authors who worked on the fourth assessment report. And I said that, really speaking, we should make much better use of those resources, modest as they were, and see whether we can catalyze action to get larger contributions and get deserving candidates from the developing countries to learn the essence of climate science. And I'm very happy to mention that JB, with his generosity and interest in helping those who are really underprivileged, has agreed to host one of the candidates, or maybe more than one of the candidates, for training from a developing country on climate science and various aspects of this huge challenge at his center. What we have instituted is basically a set of scholarships where we'll pick on deserving candidates from the developing countries and, on a priority, countries that are the least developed, because they are going to be the worst victims of the impacts of climate change. So I'd like to thank JB and his center for being part of this initiative which we have launched. Now, what I'm going to do is basically rely on the findings of the fourth assessment report of the Ipcc in trying to put forward the point of view that It's really knowledge institutions that have to take the lead in defining and practicing the imperatives of sustainable development. And one major aspect of unsustainable development is what we find by way of evidence in man-made or human-induced climate change. So let me first tell you about the Ipcc, because I'm afraid there's been an extensive amount of disinformation which has been spread about the organization. And just to give you a perspective on how we function, I'd like to present to you some facts. The fourth assessment report, which was completed in 2007, had this vast array of talent from all over the world to work on this report. We had 450 lead authors, and these are the very best scientists we can get from all over the world who actually do the writing of the report. We had 800 contributing authors, and contributing authors are basically people who are highly proficient and experts in some specific aspect of climate change. It could be someone who knows about ocean acidification, so that person writes a brief paper on ocean acidification or whatever the area of expertise is embodied in the person who's providing this contribution. And that's presented to the lead authors who make use of that knowledge, and this helps them in writing the report. Then at every stage of the drafting, we have expert reviews that are carried out. And I might mention that the expert reviewers list their comments, and the authors have to record what they do with those comments. If they accept a particular comment, they just write accepted, and they build it into the next stage of the draft. But if they reject a particular comment, they have to give reasons. And all of this is placed on a website, so it's transparent, it's available to anyone who wants to scrutinize how the review process actually took place. And I would like to go back to the initial formation of the Ipcc. We were established in 1988 through a resolution of the General Assembly of the United Nations, but we are not a UN organization. We're an intergovernmental organization. And we were charged with the task of providing international coordinated scientific assessments of the magnitude, timing, and potential environmental and socio-economic impact of climate change, and, very importantly, realistic response strategies. So our task is not merely to define or outline the problem, but also to look at solutions to the problem. And that's clearly indicated in this term, realistic response strategies. I might mention that when you define these realistic response strategies, as JB rightly indicated, some people find it inconvenient. And as a matter of fact, in the fourth assessment report, we have clearly highlighted the fact that there will be vested interests that could slow down and make it difficult to implement some of the changes that are required. So this is the charter under which the Ipcc functions. And in the fourth assessment report, we came out with some very important findings. A simple yet eloquent finding that we came up with was the fact that the warming of the climate system is unequivocal. In other words, there really is no room for questioning the fact that the climate of the Earth is warming and is changing. And I'd like to present before you some facts based on observations which clearly demonstrate this reality. Well, firstly, if we look at carbon dioxide emissions, there's been an increase of 70% in greenhouse gas emissions, and this is a package of 6 different gases that constitute what the UN Framework Convention on Climate Change has listed as greenhouse gases. And this is a very sharp increase of 70% between the period 1970 to 2004. As a matter of fact, those of you who have seen the movie An Inconvenient Truth by Al Gore might recall that he actually projected this figure, and to dramatize the steep increase that's taken place in recent decades, he actually mounted an elevator and went all the way from the bottom of this steep graph to the topmost point. I forget how much time and what distance he actually traversed, but he certainly made that point. So what this shows is a dichotomy between the fact that the world now has a UN Framework Convention on Climate Change, which came into existence in 1992, and what we've actually practiced in terms of implementing that Framework Convention. Obviously, we have failed miserably in implementing both the spirit and the substance of that convention, because greenhouse gas emissions have been going up, and they continue unabated, unmitigated. If we look at observations of changes in global average surface temperature, this is the way the plot looks if we go back to the beginning of industrialization. And what's significant over here is the fact that we have fluctuations in this temperature. And these are largely the result of natural changes, which could be in the form of solar activity, volcanic activity, and so on. But what's particularly significant is the increase that has taken place in temperatures in recent decades. If we draw a line over the plot for the last 100 years, this is the kind of slope we get, which amounts to an increase of 0.74 degrees Celsius within the 100-year period. However, if we draw a line through the last 50 years' observations, it's certainly much steeper. So in the last 50 years, you find that there's been almost a doubling of the rate of increase of temperature. This is significant, and what's even more significant is the fact that when we brought out the report in 2007, we concluded that 11 of the last 12 years rank among the 12 warmest years in the instrumental record of global surface temperature. So, based purely on observations, we find that the increase in temperature has been significantly higher than in recent years than was the case in previous periods. Now, a lot of comment from those who don't want to believe in the science of climate change seems to suggest that whatever changes are taking place, and at least now most people concede that the climate of the earth is changing, but they ascribe it all to natural factors. They'll tell you that there's a cycle in nature which causes glacial periods, the ice age, and then interglacial periods. But if you look at climate science and the modeling capabilities that have been developed in several institutions like this one itself, you find that the observations of temperature increase are roughly as shown over here in this dark line. And then if we run our models with an input of the natural changes that have taken place, those are basically solar changes, solar activity, or volcanic activity, then what you get is a range of projections essentially to validate what happened in the past, and that clearly deviates from actual observations. So this indicates that natural factors don't fully explain what has happened to temperature increases over the past 100 years or so. However, when we include inputs related to increase in the concentration of greenhouse gases, what we get is something like this. And that you would find is almost a perfect fit on actual observations. So I'm making this point only to highlight the fact that climate science has now reached a level whereby we can clearly validate past changes and observations to fit in with the predictability and reliability of climate models. One major fact that we have to be concerned with all over the world is the reduction in the mass of ice contained in glaciers across the globe. Now, this again is something which is based on observations. We find that across the entire planet, the bodies of ice that are on areas of land have been reducing in terms of the mass of ice that they contain. And in some cases, that reduction is pretty sharp. Now, this has very serious implications because the water that's stored in these glaciers has for thousands of years been providing steady flows of water which human society has become accustomed to, has based its activities on, and therefore if this is going to change in the future, we necessarily have to adapt to this change, while at the same time we've got to take action by which this kind of melting of these water towers, as they are called, in different parts of the world, can be maintained and preserved. The result of melting of these bodies of ice, as well as thermal expansion of the oceans with increase in temperature, is that we've had sea level rise in the last century of about 17 centimeters. And that's quite considerable because there are some regions in the world which are barely 3 feet or a meter above sea level. And therefore, if you get sea level rise of almost a foot, as this 17 centimeter represents, that can cause some serious problems. Every time you have a storm surge, every time you have coastal flooding, the impacts are that much more severe simply because the sea level is much higher. And what's an issue of even greater concern is the fact that average sea level has risen since 1971 at an average rate of 1.5 millimeters per year. But since 1993, that rate of increase has gone up to 3.1 millimeters per year. So sea level now is rising much faster, and that's largely because the temperature of the ocean, which was confined to the topmost layers, is now increasing and going down to the lower layers, and therefore expansion is growing. At the same time, the rate at which the bodies of ice are melting across the globe has also gone up significantly. And it's interesting to observe the average Arctic temperature has increased at almost twice the global average rate in the past 100 years. This has serious implications for the ecology of the Arctic region, and of course it has some implications for sea level rise as well. We've also found that the frequency of heavy precipitation events has increased over most land areas. And you hear about so many of these events taking place across the globe today. And you certainly can't link any single such event with human-induced climate change. But you certainly can link the trend, and the trend is unmistakable. It clearly shows that extreme precipitation is on the increase, both in frequency and intensity. We also know that the proportion of tropical cyclones reaching high intensity has increased over the past 3 decades. And in 2008, there was a terrible cyclone in Myanmar, one of the poorest countries in the world, Burma, and well over 100,000 people died as a result because the shelters they live in are flimsy. They just get blown away at a time like this, and there is no relief or transportation measure by which people can escape this kind of fury. And there's often no early warning system that tells them, like you have in the case of Florida. Every time a hurricane is going to hit Florida, people get adequate warning, and you find residents nailing their windows with strips of wood and so on, and they get into their cars or pickups and take off and go to safer locations. But that's totally out of the question in some of the poorest regions of the world. We also know that tropical cyclone activity has increased in the North Atlantic since about 1970. And again, an example of this, not necessarily linked with human-induced climate change, is what happened with Hurricane Katrina in the city of New Orleans. So these are events that are going to grow in frequency and intensity. And also, heat waves have become far more frequent over most land areas. An example of this was what happened in 2003 in Europe, where something like 40,000 people died as a result. Now, we know that if we don't do something about the problem, then continued greenhouse gas emissions would induce many changes in the global climate system during the 21st century that would very likely be larger than those observed during the 20th century. So, we have to be concerned about the impacts not only on future generations, but this very generation. And we therefore have to find ways by which we reduce the emissions of greenhouse gases. Now, what we've come up with is a set of projections of temperature increases, which is shown over here. The range is indicated over here. And you find that by the end of the century, we could have a temperature increase of anywhere from 1.1 degrees Celsius to 6.4 degrees Celsius. And to be able to focus on what might happen either at the lower end or at the upper end, we came up with what we call best estimates. At the lower end, it's 1.8 degrees Celsius, and at the upper end, 4 degrees Celsius. Now, even the lower end best estimate is something to be concerned about, because that, combined with the increase that's taken place in the 20th century of 0.74 degrees Celsius, gives you a total increase in these 2 centuries of well over 2.5 degrees Celsius, which goes far beyond what has been agreed to by all the governments of the world in Cancun, that we'll try to limit temperature increase to 2 degrees Celsius. And it certainly goes into a region where a lot of species, a lot of forms of life would be threatened by the risk of extinction. Now, there are systems and sectors that are likely to be especially affected. Water resources, particularly in some dry regions, would be affected. Agriculture in low latitudes, particularly where people are dependent on rain-fed agriculture. And the bulk of farmers across the world are really dependent on rain-fed agriculture in the poorest regions of the world. Low-lying coastal systems would be threatened by sea level rise. Human health will be affected not only because of increased floods, droughts, and heat waves, but also because of vector-borne diseases. And there are some ecosystems which are particularly vulnerable: the tundra, the mountain regions, Mediterranean-type ecosystems, etc. Regions which are likely to be especially affected: the Arctic, as I mentioned earlier, Africa, because it has very low adaptive capacity, and projected climate change impacts are going to be particularly serious in Africa. Small islands which are very vulnerable to sea level rise, and Asian and African megadeltas. And if you look at cities like Shanghai, Dhaka, Kolkata, these are a large concentration of population on the deltas of major rivers, and therefore they are particularly vulnerable because every time there's coastal flooding, you have a large number of people who would be affected and a substantial amount of property which could get destroyed or damaged. So these are regions of the world which are particularly vulnerable, and you can see them over here in this diagram. The three large dots are basically Shanghai, Dhaka, Kolkata, and also parts of the Nile Delta, where there's a very large concentration of population. We also know that climate change could lead to some abrupt or irreversible impacts. It's entirely possible. We don't know whether it will happen and when it will happen, but the West Antarctic ice sheet or the ice sheet on Greenland could collapse. Some parts of it could collapse, and if they do, and they get into the sea, then you could have sea level rise of several meters. We also know that 20 to 30% of the species that we have examined are at a risk of extinction if increases in warming exceed 1.5 to 2.5 degrees Celsius. And the Gulf Stream, which really helps to keep Europe at temperatures higher than they would be otherwise, is also being affected on account of climate change. And this could have major implications for marine life. Now, if we look at poor regions in the world, if you look at this figure, let's see what's going to happen to Africa as early as 2020. 75 to 250 million people in Africa would be exposed to increased water stress on account of climate change. And 50% of yields in agriculture in some countries could decline as a result of climate change and climate variability. So how do we respond to climate change? Well, delayed emission reductions significantly constrain the opportunities to achieve lower stabilization levels and increase the risk of more severe climate change impacts. And this is a message that I think researchers, scientists, academic institutions must spread to the rest of the world. And I think this would require a partnership between all the stakeholders of society, including governments, business, civil society, research and academic institutions. Because we have to realize that these risks and these possibilities of damage and degradation are common threats for all of us. Now, often the answer you get is, look, we don't know whether this is certain, whether it will happen. The fact is, if I have to take a flight from point A to point B and somebody tells me that there's a 5% chance of that particular aircraft crashing, I certainly wouldn't take that flight. Now, if you look at the impacts of climate change, and even if there's a 50% chance of these things happening, I think as rational human beings and risk averters and those who want to manage our risks, we would say, let's do everything possible to avoid this kind of situation. So what we really need to embark on is a process of risk aversion or risk management that gives us a secure future. Now, we have looked at emissions scenarios, greenhouse gas concentration scenarios, and if we were to stabilize the global mean temperature increase to say between 2 to 2.4 degrees Celsius, then we have to make sure that CO2 emissions peak no later than 2015. And that's just 4 years from now. And we also know that the cost of bringing about this change is certainly not anything enormous. Because let's say we were to see GDP increase globally without any mitigation, and let's say this was a steady increase, you would get a line as shown over here on this diagram. However, if we were to embark on a path of stringent mitigation, that means reduction of greenhouse gas emissions, carbon dioxide emissions, then this line just bends a little bit downwards. And what does this imply? It just means that the cost to human society is translated into a reduction of no more than 3% of the GDP in 2030. And this means that the level of prosperity that the world would reach in 2030 would at best be delayed by a few months or at the most a year. And that's certainly not a high price to pay for avoiding some of the worst impacts of climate change. What's even more interesting is the fact that there are huge health co-benefits from reduced air pollution, because when you reduce emissions of greenhouse gases, you're also reducing the emissions of local pollutants, all of which are extremely harmful to the health of human beings. So we would reap a major benefit in terms of improved health. There would be much greater employment because renewable energy technologies, for instance, megawatt per megawatt, generate much greater employment than conventional power generation technologies. Globally, there would be much greater energy security. What are oil prices today in the world? They're inching beyond $120 a barrel. And therefore, if we can somehow bring about greater efficiency in the use of energy and move to greater use of renewable energy, we would be ensuring greater energy security across the globe. So, mitigation actions can result in near-term so-called co-benefits that may offset a substantial fraction of mitigation costs. In a sense, this is like dollar bills lying on the sidewalk, and yet we are not really taking advantage of them. And this is where I think we need policies that bring about change in the right direction. And actually, there's a huge potential for mitigation of global greenhouse gas emissions being mitigated over the coming decades, and this can reduce emissions before current levels. What are the kinds of policies and measures that we can adopt? Well, certainly much greater research, development, and demonstration. Renewable energy technologies, for instance, are not getting the kind of resources that are required to bring about change in the right direction. We need appropriate energy infrastructure investments, and this would mean investments in much more renewable energy devices, far more energy efficient using devices, regulations and standards, whether it's refrigerators or light bulbs. We can come up with standards, we can come up with benchmarks which could be enforced through regulation, taxes and charges, and of course changes in lifestyles and consumption patterns. We could use much more walking, cycling, using public transport where it's available. We can switch off lights when we move from one room to the other. We can set our thermostats in such a way that we just feel a little bit of discomfort in the room and thereby cut down on energy use. And most importantly, we need a carbon price signal. I think carbon-based energy sources must show a signal that they are priced higher, and that's essential. We know that all stabilization levels assessed can be achieved by deployment of portfolio of technologies that are currently available or expected to be commercialized in coming decades. But we also need policies that provide incentives for the development of new technologies that are really going to bring about major changes in the future. So, while these policies are put in place, we certainly have access to technologies today by which we can embark on a path of reduced greenhouse gas emissions. Now, this is where I think the role of knowledge institutions is going to be crucial. They can provide knowledge on climate change, their impacts, technological innovations, etc. We need to nurture individual and collective creativity to respond to these problems. And we have to develop linkages across all stakeholders, because this is not something that research institutions or academic institutions can do very much about unless everybody else is involved. We have to spread awareness, create a common consciousness, and we have to launch a major debate in society so that new policy directions will emerge. And I think Einstein said it absolutely right. Problems can't be solved at the same level of awareness that created them. So the level of awareness that would provide solutions has to be substantially different from that which existed when these problems were created. And another very wise leader who was ahead of his time, Gandhi, said that we should be the change you want to see in the world. Now, at the start of this talk, JB showed a slide on the Lighting a Billion Lives campaign. And I'm going to request that you see a very brief film on this, which highlights the importance of dealing with a large section of human society. Can we get the sound, please? That's not the sound I had in mind. So innovation and ingenuity can really make an enormous difference. It can help to remove and reduce the burdens that human society is carrying, particularly among the most underprivileged people in the world, and it can raise a level of hope that gives people a bright future and gives them something to look forward to. So thank you very much. Great pleasure to be here. Thank you very much. I'm very grateful for this expression of support and your very kind gesture in giving me this kind of approbation for whatever I've said very humbly over here. I'll be very happy to answer any questions that you have. Well, firstly, let me say that if you look at the numbers who would be affected by the negative impacts of climate change, that clearly outweighs any benefits that you might get, let's say, in the coldest regions of the world. And we have clearly highlighted that. If you go through the fourth assessment report, we've talked about those areas where you have positive impacts as well as those where you have negative impacts. And what's particularly relevant to keep in mind is the fact that the worst victims are going to be the largest number of people who are really underprivileged, who don't have the capacity to be able to adapt to the impacts of climate change. And this is something that's not going to remain isolated. We are living in a world where anything that happens in any part of the globe is going to influence us irrespective of where we are. The other point I'd like to make is, yes, there are environmental benefits from a whole lot of things, like avoiding deforestation, by ensuring that air pollution is reduced, that the pollution of the river systems across the globe is reduced. Now, as it happens, all of these are connected with whatever you do in bringing about a reduction in emissions of greenhouse gases. And therefore, I would use the larger framework of promoting sustainable development. The very concept of sustainable development is one which says that it's the form of development which helps to meet the needs of the current generation without compromising on the ability of future generations to meet their own needs. So if we were to develop sustainably, then we would be addressing local environmental problems, we would certainly be addressing global environmental problems as well. So I don't see any conflict between the two, and one is not saying that you give up the fruits of science and technology and modern day living, but all of this can be done in a manner that minimizes the impact on the Earth's ecosystems, on the resources which are getting scarce, and the global commons which are being endangered. So there's really a complete congruence between what you've said, sir, and what I think the actions that are required to meet the threat of climate change would involve.
My name is Andreas Münchow, and I'm in marine studies, but I have a very different question. And that is realizing that advanced military planners are taking climate change now into account kind of with regard to national security and civil conflicts, especially in the poorer countries and resources. Do you care to comment on that aspect? Because you haven't mentioned it in the present context. I mean, I know Pentagon has studies, NATO is doing studies. Do you receive any support in the research efforts that go into the IPC5 from kind of strategy planning that's done by the military on national security issues?
Well, the IPCC doesn't do any research by itself. Our assessment is carried out on the basis of published material that we have access to. And you're absolutely right. There's been a substantial increase in the analysis of security and defense-related implications of climate change. And it's obvious that if you're going to have communities fighting over resources which are dwindling, which could be water, which could be reduced agricultural output, or quality land on which you can grow crops, then there's always the danger of conflict breaking out. And conflict breaking out in any part of the world has implications for the rest of the world. We have examples of that in the world today. So, yes, there's been a large number of studies recently where some of these implications in terms of security and defense implications have been highlighted. And we have mentioned the fact that there is the threat of conflict, there's the possibility of large-scale migration of climate change-related refugees. When people are displaced from their homes by climate-related negative impacts, that obviously would have security implications in other parts of the world as well. So this is something that is there in the fourth assessment report. I hope we can do greater justice to it in the fifth assessment report.
So I'm relaying a question from the University of Delaware's virtual Second Life. The person wants to know how long would it take to reverse the man-made warming of the planet if the world put into place all green energy generation in the next 10 years? And do we have that kind of time?
Well, I think that's a good question. Let me say that we have assessed, as I mentioned, that in order to come up with the least cost path of mitigation and targeting, let's say, a temperature increase limit of 2 to 2.4 degrees Celsius, then we would have to make sure that emissions peak no later than 2015. Now, this doesn't mean that if you miss the deadline of 2015, there's nothing you can do about it. The reality is, yes, you can still mitigate beyond that, but the costs will be higher, the impacts of climate change will be much worse, and therefore, if you want to make sure that the impacts are either avoided or delayed or minimized, then the sooner you act, the better. And we really don't have the luxury of time. And this is something that governments of the world have to figure out very carefully based on the scientific assessment that's available to them, and come up with a path by which we can mitigate emissions as rapidly as possible.
I'm Sanjay Gopal from Center for Energy and Environmental Policy. Please accept my appreciation for wonderful presentation, and I'm very happy. I want to ask the question, even it has a reference to what JB spoke in the introduction. We are standing in a country which is not leading. Otherwise, it is considered to be leader in many other aspects, but on this issue, it's not leading. So what do you think should be the strategy globally to deal with this situation?
Well, my belief is that you've got to spread knowledge, you've got to spread awareness. You know, fortunately, we're all part of democratic societies. And I think if the public wants a particular set of actions or policies, our leaders are smart enough to realize what's expected of them. And I think there is no shortcut to information dissemination, of knowledge creation, and this is where I think institutions like this have a vital role to play, not only in terms of practicing what they believe would serve the interests of society generally, but perhaps even reaching out to the community. Because I think the strength of US society is its institutions of higher learning. And if they can be the engine of change, then that change certainly will make a difference. So in my view, we shouldn't despair. We shouldn't feel at all despondent about any lack of action anywhere, because happily in this country there are examples of, states and cities that are doing extremely well. But we just have to scale up these efforts and make sure that this becomes part not only of a movement in this country, but globally.
Question.
How can people my age do something like about the planet?
Well, I'm delighted to hear from you, because I think it's your future which is at stake. So there's several things you could do. In your schools, you could launch efforts by which you try to make your schools carbon neutral, environmentally responsible. You could also go out to the communities where you live and try to mobilize the youth living in those communities to get down to action. And importantly, you could also shame adults into doing the right thing. Because you have no idea how much moral force you have. If you tell your parents and their friends that they ought to use more efficient lights, or every time they move from one room to the other, they should switch off the lights, I assure you they'll listen to you. So you can make a difference, and I hope you will. All right?
Another question. Are there any credible models showing where the tipping point is?
How one defines the tipping point is really something that involves a value judgment. If you look at a poor farmer in a very poor country who is dependent on rain-fed agriculture, and all he or she produces is enough to meet the very barest minimum of requirements of the family, and let's say precipitation patterns or decline in water availability makes that impossible, then I think from the point of view of that individual, he or she has already reached tipping point. But the question is, if we are looking for a global average, then we're obviously ignoring the rights of others to live on this planet and to be able to lead an existence which has some degree of respectability and some degree of opportunity to be able to, progress in life. There are parts of the world where you see people in decline. So I think that's really a value judgment. I mean, how do we define a tipping point? And I'm not sure whether our global institutions have been able to come to grips with this issue. I think there's a certain moral, ethical, and equity dimension to the issue of climate change, and we are hoping that we can address that a little better in the 5th assessment report.
Could you address whether nuclear power is sustainable, clean, green, et cetera? It's part of the Obama administration's package, and there's a huge amount involved with getting the fuel, the uranium processing, creating it, cooling it, the water, and now we see what's happened in Japan.
Well, in the 4th assessment report, for the first time we assessed nuclear power, and we have said that, it meets 16 to 17% of the total electricity supplied in the world. but we've highlighted all the problems associated with nuclear power. So we haven't sort of brushed that under the carpet. But I think it's for societies to take a decision on what they regard as the choices available to them, and they have to take these decisions with their eyes open. You have countries like France, where almost 80% of the electricity comes from nuclear energy. There are other countries where nuclear power is literally outlawed, and you're not allowed to install any nuclear power generation facility. I think what we really need to do is to provide all the information that pertains to nuclear power generation. And then it's for people to decide, and people also have to make sure that they have the technical skills, they have the institutions by which nuclear power can be managed. And we have really not taken a position on this because the Ipcc is not required to take positions on anything, but we have carried out a very fair and objective assessment of the problems and the potential of nuclear power, and we would just leave it at that. There are undoubtedly problems associated with nuclear power, which we have highlighted very clearly.
Good evening. My name is Adam Smargan. I'm with the Center for Energy and Environmental Policy here at UD. And you had mentioned that there are an awful lot of people who would be losing either economically or politically if the IPCC succeeds with advancing the solutions for climate change. And there are a number of people in this country and other developed countries that swear up and down that climate change is wrong, it's a hoax, etc. You've heard everything before. What can be done, if anything, to win over hearts and minds? What advertising, what marketing, what other persuasive methods can be used to really convince people that this is a real threat that truly threatens humanity?
Well, I think that's a very good question. And, you know, to my mind, if you look at changes and the emergence of new knowledge historically, you find that whenever a new body of knowledge has emerged and it challenged conventional ways and conventional wisdom, there's always been inevitably a resistance to accepting that. And I think we were perhaps naive in believing that whatever we came out with would be accepted and implemented. Even though, as I said in the fourth assessment report, when we've talked about changes in the energy supply industry, we have clearly said one of the barriers is the action of vested interests. And these vested interests would certainly come into play. And some of them, if I may say, have access to resources, are very well organized. But in the end, I think truth will triumph. And all we can do is to make sure that we keep doing good quality work as far as scientific assessment is concerned, and make sure that our message goes out. We have not been very good at spreading the message. And I think we need to do much better in that regard.
I was wondering if you believe that it is possible to develop at a sustainable enough level to maintain a reasonable standard of living for a globe with 9 billion people in the future?
Yeah, I think it's really a question of the kind of standard of living that one wants. You know, if you look at developed societies even today, there are substantial differences in the way they use energy, the way they use resources. Even among the developed world, there's a substantial disparity in terms of energy use. And that clearly highlights the fact that there are means by which you can use energy resources far more efficiently than we've become accustomed to. And I think if you give yourself enough time and innovation to take place, whereby, let's say, energy that we consume at very high levels today could be provided by sustainable forms of supply, by renewable energy technologies, by more efficient uses of technology, we really don't have to give up much of our ways of living and our standard of living. So I think it's possible. It's certainly not something that's going to happen overnight, but the sooner we embark on this transition, the better off we would be, and the easier it would be for us to make adjustments to new forms of energy, new patterns of usage, and much lower levels of emissions of greenhouse gases. So, in one word, the answer would be yes, we can do it. It's entirely possible.
Yeah, Stanley Sandler, chemical engineering here at the university. First, I just want to make a comment. I remember that our former Vice President, Dick Cheney, got us into Iraq with the comment, if there was even a 1% chance, we had to do something. And I think the probability here is much higher than 1%. But my question has to do, again, with the tipping point. If the ice packs melt, the reflectivity of the Earth decreases, global warming should then increase even faster. Is there any estimate of the point at which the planet could just not recover?
Yes, as a matter of fact, I think what we would be able to do is provide much better insights into that in the fifth assessment report. You know, the problems of permafrost, for instance. Once you get a melting of the permafrost, you would get much higher emissions of greenhouse gases from those parts of the world. On a quantitative basis, I think we have much more information today than we did, let's say, 5 or 6 years ago. So I'm hopeful that we can provide much more information and knowledge on these aspects now than we were able to do earlier. Whether we can come up with a very clear date or definition of where that tipping point lies, or where you get into runaway climate change without being able to reverse it, I'm not too sure. It appears to me that we're probably not anywhere in that zone at this point of time. But I expect in the fifth assessment report we'll be able to provide much better insights into answering this question.
Our last question.
Has the Ipcc looked into contingencies in the event we do reach the tipping point in dealing with climate refugees such as colonizing the northern tip of Antarctica?
I'm sorry, colonizing?
Yeah, colonizing the northern tip of Antarctica.
Northern tip of?
Antarctica.
America. Antarctica, oh. I'm afraid we haven't done that.
I think the colonizing of the refugee issue is important.
Well, I think the refugee issue is certainly a very important issue because, you know, there are parts of the world where, as I mentioned, on account of conflict over depleting resources or resources that are under stress, you could get a disruption of peace and stability. And that would mean that you'll have a large number of climate-related refugees, and where they go, where they settle, is something that is very difficult to predict. But, I mean, I mentioned in the United Nations General Assembly in 2009 that you could get the possibility of failed states as a result of some of the stresses that we are likely to see. And we must remember that climate change exacerbates some of the existing stresses. We know that there are parts of the world where stresses and conflict exist even today. And climate change would make these much more acute. And if that happens, yes, you would get refugees. You would get people who are driven from their own homes. And where they go and what kind of implications that carries is something that has to be considered very carefully.
The program will be in podcast form available on the Denon website. If you would like to consider getting involved in Lighting a Billion Lives, you can see the web address right there, labl.terein.org. And can we give our good colleague and friend, Dr. Pachauri, a good hand?